Okay, so let's pick it up where we left off in the last video. I think what we had is 2 times y minus x dy dx equals the integral from x to 1 of square root of 1 minus dy dx squared dx. Okay. So what I'm going to do is I'm going to distribute that 2 into the bracket on the left-hand side so that I can stretch this guy out. And then I'm ready to take the derivative of both sides of the equation. So for the left-hand side, the derivative is for the 2y is just 2 times dy dx minus, and here I've got a product rule to take the derivative of. So if I take the derivative of the first term, it would just be 2, and then I multiply that by dy dx. And then I would add the derivative of the second term. So the derivative of a derivative is just the derivative squared, and we write that like this to show the double derivative. And then that's multiplied by the first term, which is the 2x. Okay, and I put brackets around that because this negative has to come in and be distributed into the bracket in a minute, so that's going to change the sign there. And over here, the derivative of an integral is just the function itself, and so we end up with 1 minus dy dx squared, like that. That's what he's referring to with the fundamental theorem of calculus, okay? So if we clean up over here, we're going to get 2 dy dx minus 2 dy dx. So that's good because those guys will cancel out. Minus 2x times the double, or the second derivative, the d squared y dx squared, equals the square root function over here. Almost there. All right, this is where it gets exciting because 2 dy dx minus 2 dy dx, that's 0. So I have negative 2x d squared y dx squared equals square root of 1 minus dy dx squared. We have one more step just to make this look like the equation he gave us, which is to divide both sides by minus 1, so we get 2x d squared y dx squared equals negative 1 minus dy dx squared. Okay, so that brings us to a little bit of a crossroads in the problem, because the next step, if you've read through the assignment that you sent me with that solution, the next step is to now try to solve this integral, and it's not easy. So he's using maple to do it, and I'm just wondering if what we need to do is gosh, what do we need to do? Not sure. I gotta think on that for a minute to try to solve this. I'm just wondering if we can use Simulab instead of Maple and just kind of cite that, like I use Simulab for this part of the solution, because he's expecting you to use some kind of software, even though he's not explicit about that in the assignment that he gave you. It's pretty clear in the last assignment when he posted the solution to it that he was expecting people to use it. So that seems fair. So let's quit there, because that takes you to the point where you've got the function that he was asking you to show that you have. The other stuff, like the dy dx equals 0 when x equals 1 and y equals 0, that's all part of what we're going to need to solve this equation. I've just got to find an easy way to do it. Maple may be your only chance, which means that you would have to, if you have Maple at home, you would have to figure out a way to get that into the program and follow the steps that he wrote on his solution, which is not easy. There's a lot going on there. It's way, way above the heads of people in this course, and that's what had me worried when I gave up last night. So let me see what I can do. I'll send you this video and we'll go from there.